What is sound? What is sound? Sound is a form of energy like heat, light, etc. Sound is also one of the forms of energy. It is this sound energy that gives the sensation of hearing in our ears. It produces the sensation of hearing in our ears. It is sound energy. It is produced by a vibrating body. So, a source is a vibrating body. It travels in a material medium. It travels in all the materials, solids, liquids, and gases, in the form of compressions and refractions, and it is a longitudinal wave motion. It is a longitudinal wave. It is produced by a vibrating body. It travels in the form of compressions and refractions, and it creates the sensation of hearing. It is a longitudinal wave. Production of sound. Which body produces sound? We know that a vibrating body produces sound. Sound is produced by a vibrating body. How do you know it? Touch a ringing bell, a cycle bell. You notice that it is vibrating. Pluck the string of a violin, musical instruments, or a stretched string. When it is producing sound, touch it. You will notice that it will be vibrating. Excite a tuning fork. You will hear sound. While producing sound, touch the tuning fork. You will notice that it will be vibrating. To understand this phenomenon physically, if you want to visualize this, vibrate a tuning fork, suspend a small plastic ball at the end of a string from a peg, and keep the vibrating tuning fork in contact with the ball. You will notice that it will be pushed away, it will be kicked away by the tuning fork, which indicates that the tuning fork is vibrating. Like this, we can understand visually or by touch that the source of sound is a vibrating body. We can prove that a vibrating body produces sound visually as well as by means of touch. How do we produce sound? How human beings are producing sound? We notice that there is a part known as vocal cords in our throat, in our throat, and these cords will be vibrating. The vibrations of the vocal cords produces sound. So we produce sound by vibrating our vocal cords. Propagation of sound. How sound propagates? How the sound propagates? We notice sound is produced by a vibrating body. What is a vibrating body? A body which moves to and fro, which moves about an equilibrium position. It moves to one side and comes back and moves to the other side. Once again, it comes to the equilibrium state. Like this, it will be continuously moving. Its motion is called to and fro motion. So a body with to and fro motion is said to be vibrating body. When a body is vibrating, if it is in air, then it hits the air particles which are in contact with it. The air particles which are in contact with the vibrating body are hit by this vibrating body. Then the air particles will be set in vibration. They will also undergo to and fro motion. They hit the particles in contact with them. They hit the particles. They hit the particles which are nearby them, and those particles will be set in vibration. And those particles will be set in vibration. They in turn they also vibrate, they also vibrate, and once again they hit the particles, nearby particles. Thus, each particle which is set in vibration hits the neighboring particles and set them in motion in vibration. They in turn set the other particles in vibration like this. The particles one after the other will be set in vibration. Hence, the energy flows through these particles. The energy flows through these particles. Like this, the energy is propagated by the vibration of the particles. Then, how do we visualize and we study this propagation of sound? While vibrating, a group of particles, when the vibrating particle moves in the forward direction, the air layers will be compressed. The air layers nearby it are compressed. So the pressure increases and the density increases in a small region. This region is called a compression. This region is called a compression. As soon as the compression is formed or the vibration is, the forward motion is complete, it moves in the backward direction. The vibrating body begins to move in the backward direction. When it begins to move in the backward direction, the same region in which pressure and density are high, it slowly decreases, the pressure and density decreases, and it will be less than the normal pressure and density. Such a region is called rarefaction. So the same region which was a compression, it will become a rarefaction, less density and less pressure region. Meanwhile, the higher density, higher pressure region will be formed nearby it. That means the compression passes in the forward direction. That means a high density, high pressure region is formed beyond the rarefaction region. Once again, when the vibrating body comes in the forward direction, once again compression is formed. During this process, the already formed compression and rarefaction, they move forwards like this. By the vibration of the body, compressions and rarefactions will be formed. During this formation, the already formed compressions and rarefactions, they move in the forward direction. Like this, we notice formation of compressions and rarefactions and the propagation of compressions and rarefactions in a medium. Here, what we have to understand is the vibration will only be transmitted, but the particles will be vibrating about their mean position. The air particles will not travel, but their amplitudes of vibration will change. They will vibrate. They will only be vibrating and transmitting energy, and thereby compression and rarefaction will travel, but not the particles. The particles will remain where they are, and they will be vibrating about their mean position. Now, the formation of a compression or a rarefaction, it is termed as disturbance. Disturbance. A region of compression is disturbance. A region of rarefaction is a disturbance. So we name compressions and rarefactions as disturbance. Since compressions and rarefactions, they travel in the medium, we call them as propagation of disturbance. Propagation of disturbance. So sound is defined as the propagation of compressions and rarefactions or the propagation of disturbance. Like this we define. Sound is defined as the propagation of disturbance. Sound wave needs a mechanical medium for their propagation. It cannot pass through vacuum. It can pass through the substances only. It cannot pass through vacuum. How do you prove this? To prove this, an experiment is conducted known as bell jar experiment. We can prove this using a bell jar experiment. In the bell jar experiment, you notice a bell jar to which a cork is fitted. Through the cork, electrical wires are passed. Electrical wires are passed through the cork, and they are connected to an electric bell placed inside the bell jar. At the bottom of the bell jar, a tube is inserted which is connected to a vacuum pump. By switching on the electric bell, we notice sound of the electric bell. If we slowly remove the air using vacuum pump, if you slowly remove the air inside the bell jar, you notice the sound becomes faint. Its intensity will be slowly decreased, and finally we cannot hear any sound. We cannot hear any sound when it is completely empty, when it is vacuum. So when vacuum is created inside the bell jar, then there will be no sound. This indicates this experiment indicates that sound cannot travel through vacuum. It cannot travel through vacuum. By introducing the air once again, we slowly hear the sound and becomes louder and louder until it reaches its normal stage. So this experiment proves that sound needs a material medium for its propagation.